In this video, we'll be looking at calculating the volume of a solid, particularly a prism. So, in the previous video, we looked at calculating the total surface area, and our solution was 263.96 square centimeters. And now we're looking at volume, which is in cubic centimeters for this question. Now, what is a prism actually? Let's quickly review that. Now, a prism is basically a solid where you have a uniform cross section all the way through its length. So here we have a solid, and what we have is this face that is a polygon. But what type of polygon? A pentagon. 1, 2, 3, 4, 5. 5 sides, and so we say it's a pentagon. In fact, each side is equal, so it's a regular pentagon. Now, should we slice this off? Cut this shape here, or this face, cut it off along here, uniform, all the way through. Then we will still get this face again. Keep on cutting, we'll still get this face, or slices of this face all the way through this length. What does that mean? It means it's a prism. So if we want to calculate the volume, then we'll have to find the area of the uniformal cross section, meaning this face and this face are identical all the way through, right? And so finding the area of this and then multiply by the distance between both these uniformal cross sections. So this is a cross section that's uniformal all the way through to this side. Okay? So that's how we find the volume. Similarly, a pentagonal prism, a triangular base prism. Similarly, if you want to find the volume, find the area of the uniformal cross section, multiply by the distance between both uniformal cross sections. This is also a prism, which is a cylinder. We'll call it a cylindrical prism or circular base prism. If we slice this all the way through, we'll get the same face all the way through, all congruent right until the end. All right, so this face and this face are identical. It's maintained all the way through. So once we find the area of this base, multiply by distance between both of these faces or both base, then we'll get the volume as well. So that's how we find the volume of a prism. Area of cross section multiplied by distance between both uniform cross sections. Okay, now when we look at the shape that we're given here, or should I say the solid that we're given, notice that this side here, let's pay attention to it, this side here is uniformal all the way through until we meet the end down here. I mean, this is just one way of calculating the volume. We'll look at another way after we do this one. So if I should cut along here, in other words, let me see, let's say I should cut along here, right? Cut along here with a knife, with a good cutter that will cut it evenly all the way through here. What would happen? What will happen exactly? Right? Is that we'll get a face that looks just like this one. And if I keep doing it, keep cutting slices all the way through, right? And it's uniform all the way through. What do you think will happen? We'll still get a face that's identical to this face here that we have here. All right, we'll get a face that's identical to this face. So all the way through, that means that this is a uniform. It's a uniform cross section. And once we have a uniform cross section along the length of a solid, then we say it's a what? it is a prism. And we basically calculate the volume of a prism. We'll be doing part B, by the way. Calculate the volume of a prism by multiplying the area of uniform cross-section multiplied by the length. In other words, the distance between both uniform and cross-section. So the area times length, in other words. All right, with area referring to the cross-section. All right, so are the uniform cross-sections. Now, in order for us to calculate the area of the cross-section, we look at the fact that this is what? This is a rectangle, but a special rectangle, because when we look at the lengths of the sides, right? This side here is 4 centimeters, as we can see. This is 4 centimeters on top, right? Here's 4 centimeters. We know this length and this length are the same. And here, right up here, that's basically, let's go across the other face. We're told that this is actually 4 centimeters. So this must also be 4 centimeters. So basically this would be a square. And the area is equal to base by height or length by width, which is 4 times 4, which is equal to 16 square centimeters. We need to also find the area of this shape here. Now this shape here is a semicircle. Right, so to find the area of a semicircle, it's going to be half the area of the circle. Area of complete circle, right? So it's going to be half. The area of the circle is pi r squared. So it's going to be half of what's pi? 3.14 times the radius. We established before that the radius, now again, this is a shape basically, like going all the way around. That's a circle, all right? Not draw the scale obviously. And this portion here, from here to here is 4 centimeters. That's what we have here. This length here is the diameter, because remember this is a semicircle. All the way around here, that's a semicircle. If we had gone all the way around, that would be a circle. We're looking at the fact that we have a semicircle, and this is 4 centimeters. So half of it is 2. So r is 2. We square that. So what we're gonna get half of 3.4 times 4. Okay, so using our calculator, we have half being 0.5 times 3.14 times 4. And that's going to be 6.28 square centimeters. So combining them, the semicircle plus the square, right? Area of cross section the area of cross section is equal to 6.28 plus 16. That's 22.28 square centimeters. And so the volume of the solid will be area of cross section multiplied by the length between both cross sections. And the area of the cross section we got is 22.28 square centimeters multiplied by the length between them, which is 12 centimeters. So let's put that in. 12 times 22.28, and that will give us 267.36 centimeters cubed. Now, area times length give us volume. Now, centimeters squared times centimeters give us centimeters cubed. So centimeters squared is really centimeters, or length times length, right? Centimeters times centimeters in this case, multiplied by another length. So it's length times length times length, which is centimeters cubed. 1, 2, 3. to give you volume. Length by length, that's area. Area times length, that's volume. That's it. Another way you could have done this though, there's another way you could have done this, which would be simply to do what? You could calculate the volume of the cuboid, and the volume again is the measure of the amount of space occupied by a solid. See the amount of space occupied by this solid here. All right, we can find. All right, by finding the area of the cross section. So we're talking about the volume of the cuboid, or should I call it rectangular prism. So we find the area of the cross section, which is 16, multiplied by 12. That will give us the volume of the rectangular prism. So let's try that. Let's see if we'll get the same answer. All right, so I'm gonna just put that neatly somewhere quickly. So the volume for this, the top one, is area of the cross section, which is 16 centimeters squared. We worked that out already. It's right here. Area for this cross section. That's uniform all the way through to this end here. So that's 16 square centimeters. Let's find the area of one. I'm going to multiply by the distance between both uniform cross section, which is 12. And the volume, 16 multiplied by 12, give us 192. And since it's centimeters, that will be centimeters cubed. Now for down here now, again the volume is going to be area of the cross section times the length between our distance between both uniform cross section. And the area for this cross section, which is half of the circle, it will be what? Remember, we actually worked that out already. Half of the area of the circle, so that's half of pi r squared, and we got 6.28 centimeters squared. I'm going to multiply that now by the distance between them, which is 12. And so we're going to get 6.28 times 12. And that's going to give us 75.36. Now when you add these two answers together, remember you want the volume of the entire shape. It will be 192 plus 75.36. So the volume, or the total volume in that case, of the entire solid, or the volume of the solid, the compound solid that we have there, will be 192 plus 75.36. Their answer will be 267.36. So we got the same answer basically. All right, so we did calculate the volume, and part C, we're told that what? We're told that the solid is made from gold, and that 1 cubic centimeter, so 1 cubic centimeter of gold has a mass of what? 19.3 grams. So if 1 cubic centimeter of gold has 19.3 grams, it means therefore, or it implies that what? That the 267.36 cubic centimeters of the gold, or of the gold that solid is made from, will have what? If 1 cubic centimeter has this, then 267.36 would have 267.36 times what one has, which is 19.3 grams. And this will give us what? 5,160.05. I mean at least two decimal places, right? Grams. That will be the mass of this entire solid. Now we're told that the cost of 1 gram, so in other words, 1 gram of gold is our cost. Let's put cost. Costs $42.62. So if 1 gram costs $42.62, then imagine what 560.05 gram would cost. Of course, it would cost what 1 costs times the amount, which is 5160.05. It's like saying 1 apple costs $5. What's the cost of 10 apples? You take what 1 costs and multiply by 10. So it'll be $50. Does that make sense? Reason on it. Okay, so that's not what we're talking about though. We're looking at the fact that 1 gram costs $42.62 and 5,160 grams would cost $42.62, the cost of 1, times this amount. And so that will be equal to, and then we get this amount.